Okay, I thought I'd do the absolute pitch question in a video rather than doing it in front of everyone. It might make a bit more sense visually. I'm going to try and make this super quick. Item 25, I've got the questions over here and I've got the graph over here. So in relation to the ability to recognize piano tones relative to pure tones, which of the following statements is consistent? Okay, so we're after consistent. Which one fits? I've marked in the correct answers, by the way, so we know the answer is going to be A. Recognizing piano tones is easier than recognizing pure tones. Well, if we're saying recognizing piano tones is easier, that means more people are going to score higher on piano than they are on pure tone. So let's have a look over here at our graph. Okay, we've got a nice easy bunch up the middle. Are there people who are scoring high on piano but not so high on pure? Yes, there are. Are there people who are scoring high on pure but low on the piano? That's this region. Well, they've put the key in the way, so presumably there's nothing there. Okay, so that fits with this. Recognizing piano tones is easier than recognizing pure tones. That's the correct answer. I won't go through the others because that one fits. Okay. Give the classification of data points in figure 1. Which of the following best reflects the minimum score needed for having AP? Okay, well, AP is the black dots. Okay, so that's our black dots through here. What is the minimum for getting a black dot? Okay, well, the easiest way to do that is to go ahead and graph though and draw the lines on. Okay, pure tone score greater than 15 and greater than 25 is that. Okay, so this is that area there. Okay, is there any data outside of that? This poor guy here. Okay, so that one doesn't fit. Next one, pure tone score greater than 25 and greater than 25. Okay, is there any data outside of that? Yeah, heaps. Okay, he doesn't fit. Next one, pure tone score greater than 10 and greater than 25. Okay, well, is there black data outside of that? No, so potentially that's the right one. And D, pure tone score greater than 25. That was horrible. Greater than 25 and greater than 20. Okay, any data outside of that? Yes. So the best answer is going to be C. Item 27. Which of the following offers a reason for use of the electronic pure tone generators in assessing AP that is consistent with the information given? Really important, based off of the information in the passage that's up top, okay, which is all the way up this one here. So we've got 4 statements, okay. Individual ears respond differently to piano tones, but yet respond differently, similarly to pure tones. There's no information in the text to support that. Using only scores derived from musical instruments necessarily yields inflated AP scores. Well, there's no information to support that. Pure tone scores provide a check on the variability of scores from tones derived from different musical instruments. Okay, so we've got pure tone scores provide a check on the variability of scores from tones derived from different musical instruments. Is there information to support that? Potentially. Let's go and have a look. Okay, I've underlined a blue section here. It says pianos produce tones that are more complex than pure tones, but which are characteristic for the instrument. Okay, so we have a variability of tones derived from musical instruments, and the pure tones give us, a baseline check to compare those two. So that one fits. And D, the human ear is now more attuned to music generated electronically, and this needs to be structured into design. No, well, there's no information about that in the text. So the best fit for the information given is C. Item 28. This one's quite tricky. Okay, the easiest way to do this is to plot these points. Okay, you need to know what the word respectively means. It means that if I give you a list of 2 things, pure, in this case, paired scores for pure and piano tones, respectively, it means that these numbers are, first number is pure, second number is piano. Okay, so I'm going to go and plot these over on this side. We've got 19, 32, we've got 25, 30, we've got 26, 29, we've got 21, 28. Okay, so looking at this, I can sort of make an educated guess to say that these guys are all going to be AP1, maybe AP2. Okay, so those ones are there. There's my next band. Okay, let's look at what our original AP. We've got only one data point to show us what AP3 is. That's this. Okay, which one's the closest to that? Well, it's this guy. Okay, we can make an assumption that this one here is going to be lumped in with that AP4. The graph does seem to favour people who have a higher pure tone score for a higher AP value. So we've got two data points to make a judgment between. We're under the pump. We're going to go with that point is our AP3 point, which is B. Moving on. Item 29. If there were 50 subjects in the experiment, which bar graph best represents the combined scores in respect to piano tones? Okay, so we're not looking at comparing piano and pure tones. We just want to look at piano tone score. So let's ignore the fact that there are pure tones on here, and let's see if we can't match up these bar graphs to the graph data over here. Okay, well, let's look at what the graph is. We've got percentage of total, we've got score on the side. Here's 0 to 4, okay, has that much percentage of the total. Okay, so let's see if we can turn this data into a bar. We've got how many people, so 0 to 4 is here, okay. How many people are in there? Well, let's try doing this. 3 people, okay. How many people were here? That's 4. How many people in the next band? So the next band is 10 to 14, okay. There is 10 to 14. How many people are in there? That's 4. Okay, how many people in 15 to 19? Well, that's going to be 3. How many people in the next band? We've got 20 to 24, that one. Oh, 20 to 24 is here, which is those people, not including the ones on the line because they're 25. It's 1, 2, 3, 4, 5, 6. And the next lot, 25 to 30. Okay, 1, 2, 3, 4. 4. Back down to 4. That's interesting. And then how many in the 30 to 34? A lot. And then how many above 35? It has a bracket 35 to 39, so it's up here. How many in there? A couple. Okay, so let's see if we can match up those to the graphs. Okay. Well, I know the answer is going to be A, so I'll show you why A works. Okay, let's have a look. We've got 3, 4, 4, 3, 6, 4, a big bar and a smaller bar. So we're looking for a bar, 2 bigger bars, one that goes back down, goes back up, goes higher, comes back down to same as those. Yeah, and then a big bar and a small bar. So I'm going to go and look and try and match up the graphs with that pattern. And I can see over here I've got 3, 4, 4, 3, 6, back down to the same level, 4, big bar, small bar. That one fits. Okay, the other ones don't fit. Okay, because say this one is 3 and then it's a higher amount and an even higher amount. Okay, well that doesn't work. This one's the same. And then we look at this graph over here. Okay, so 3, 4, 4, 3. This is working so well. 6 comes back down to the same level. That works. Oh, we're up high. Hang on. The only difference between that one and that one is that bar. Okay, so you've got to make a call. It's a percentage of the total. This one goes across and it's 20%. This one goes across and it's about 22%. No, 24%. Okay, how many, you go back here and count How many is there? That's 10. You got 10 out of 50 people. That's 20%. Okay, because that's 1 out of 5, which if you do on your calculator comes out 2.2. So that means that the first graph, A, is going to be the correct one. And that's the absolute pitch question done.